Namaste to everyone. I welcome you all in my YouTube video channel. Today I will deliver lecture on tensor analysis, lecture number 10, which will include the metric tensor and its related topics. Now I will discuss on fundamental contravariant tensor. As we already know that Gij is a metric tensor which is symmetric and covariant of rank 2. It is said to be fundamental covariant tensor. But today I will discuss fundamental contravariant tensor. Fundamental contravariant tensor is conjugate of metric tensor. As we know the property of conjugate, that Gij is the conjugate of this Gij. This is equal to Aij by G. G is the determinant of Gij. This is G. This contravariant Gij is called fundamental contravariant tensor. Now we shall see its properties. Now determinant of Gij. Determinant of this Gij will be determinant of Aij by G n by n. This will be equal to 1 by G to the power n. Determinant of Aij. Aij be the cofactor of this Gij, and this will be equal to G to the power n minus 1 by G to the power n equal to 1 by G. So if a determinant of covariant, this Gij, is G, then determinant of contravariant Gij is 1 by G. Next we know the property of the conjugates as Gij Gjk equal to delta I k, implies that Gij, this is symmetric, conjugate tensor is symmetric, Gkj equal to delta Ik. If we take k equal to I, then this will be delta II, and this is equal to n. So Gij and this Gij equal to n. These are the properties. Number 1, determinant of contravariant Gij equal to 1 by G, and Gij equal to n. Also this will be used in later cases. This Gij and this contravariant Gjk equal to delta Ik. Now we will discuss about associate tensor. A covariant vector Ai is said to be associate to Aj if Ai equal to Gij Aj. Then Ai associate to Aj. This is the covariant, this is contravariant. Now we shall prove a theorem. If Ai equal to this, then AJ equal to GIJ AI. Taking GIL product with both sides, this equal to GIL GIJ AJ, implies that this will be delta L J AJ. Here J is a dummy suffix, so if you take J equal to L, then this will be 1, otherwise 0. So this will become 1 if J equal to L, implies that AL equal to GIL AI. Putting L equal to J, we get AJ equal to GIJ AI. Proved. Now we will discuss about magnitude of a vector. A magnitude of a vector AI is defined as A, which is equal to A square equal to GIJ AI AJ. Now we calculate this with the knowledge of associate tensor. This will be AJ and AJ. This is number 1. Now we write GIJ AI AJ equal to, this will be AJ, taking this, and this will be, this is the AJ by commutativity, AJ AJ, this is 2. From 1 and 2 we get right side equal, so this GIJ AI AJ equal to AJ equal to GIJ AI AJ, and this equal to A square GIJ AI AJ is 3. So from this equation and this equation we see that left hand side equal, then right hand side equal. Here right hand side is GIJ AI AJ, which is the square of the magnitude of the tensor. Here is square of the magnitude of the tensor. Here we take the magnitude of a covariant vector or tensor of rank 1. So we may define also, this is the expression for the magnitude of contravariant vector of rank 1. We shall define angle between two vectors. Let AI and BI be two vectors, and let angle between two vectors be theta. Then we define cos theta equal to GIJ AI BI square root Gij Ai Aj square root GPQ PBQ. This is the required expression for angle between two vectors. Now we shall solve some problems. Here there are three problems. We shall solve one by one. Number one. For number one, we write G mu alpha, G mu nu. Already we have seen this. The value of this is alpha nu, mu common, and this will be equal to 1 for nu equal to alpha and 0 for nu not equal to alpha. Differentiating both sides, d g mu alpha g mu nu equal to 0, as right side is 1 and 0, derivative of 1 and 0 is 0. So we may write this d g mu alpha, differentiate from first, second constant g mu nu plus g mu alpha d g mu nu equal to 0, implies that d g mu alpha g mu nu equal to minus g mu alpha d g mu nu. Now multiplying both sides by g nu beta implies that d g mu alpha g mu nu g nu beta, this side also minus g mu alpha g nu beta d g mu nu. Here we see that nu is common, so this will give the result d g mu alpha. This will give Kronecker delta mu beta, and this side minus g mu alpha g nu beta d g mu nu. Here mu is the dummy suffix, so when mu equal to beta, then value of the Kronecker delta will be 1, otherwise 0. So this value of mu we write beta, implies that d g mu, value of mu is beta, beta alpha, this is 1, equal to minus g mu alpha g nu beta d g mu nu. As g beta alpha is symmetric, so we may write d G alpha beta equal to minus G mu alpha G nu beta d G mu nu. Proved. Now we shall solve number 2. Multiplying both sides of this equation by A alpha beta. Then A alpha beta d G alpha beta equal to minus A alpha beta G mu alpha G nu beta d G mu nu. As we have seen the associate tensor, so value of this will be minus A remains beta and here mu, G nu beta d G mu nu. Here B the dummy suffix. So by taking the concept of associate tensor, so we will get minus A mu nu d G mu nu. As mu is the dummy suffix and nu is also dummy suffix, we replace mu by alpha and nu by beta. We will get minus A alpha beta d G alpha beta. So number 2 is proved. We shall solve number 3. Let G be the determinant of the matrix G11, G12, G1n, G21, G22, G2n dot 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 Gn1, Gn2, Gnn. This is the value of the determinant of metric tensors. If we differentiate both sides with respect to xk, del G by del xk. Firstly differentiate first row, del G11 by del xk, del G12 by del xk dot 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 del G1n by del xk, G21, G22, G2n dot 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 Gn1, Gn2, Gnn plus differentiation of second row. First row remains same, G11, G12, G1n del G21 by del xk, del G22 by del xk dot 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 del G2n by del xk. Other rows remain same, Gn1, Gn2, Gnn. And next we differentiate third row and plus next differentiate fourth row, and lastly we differentiate last row, nth row. So this will be G11, G12, G1n, G21, G22, dot dot dot, G2n, del Gn1 by del xk, dot 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 dot, del Gnn by del xk. If we take determinant, we get cofactor of this element multiply by this element plus cofactor of this element multiply by this element. So we write A11 del G11 by del xk plus cofactor of this is A12 del G12 by del xk plus dot 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 A1n into del G1n by del xk. Now taking determinant of this, we take the second row and its cofactors. Let cofactors of this element is A21. So we write A21 del G21 by del xk plus A22 del G22 by del xk plus dot 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 A2n del G2n by del xk, and we take other determinants also. Lastly we write determinant of last determinant. In this case we take the nth row and multiply with its cofactors plus an1 del Gn1 by del xk plus an2 del Gn2 by del xk plus dot 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 ann del Gnn by del xk. Now we see that first line this is A11 G11, A12 G12, A1n G1n, A21 G21, and similarly we get all terms, and in short by using dummy suffix we may write this equal to Aij del Gij by del xk. I and j with the dummy suffix, I and value of ij is 1 to n. Left side is del G by del xk. Now multiplying both sides by dxk, del G del xk into dxk equal to Aij del Gij by del xk dxk. Value of this will be D G, as this is k equal to 1, 2 and so on, and right side this is the cofactor of Gij, and we know that Gij equal to Aij by the determinant, implies that Gij equal to Aij. Putting this value here, we get Gij, and this will be Dgij. So we will get Dg by G equal to Gij Dgij, using 2 here. If we take in place of A G alpha beta, means G alpha equal to I, beta equal to J, then Gij into Dgij, this will be the same. So in right side we may write minus G covariant Gij into D contravariant Gij. So we may write minus Gij Dgij, replacing the dummy suffix I by mu and J by mu, we will get value of this is minus G mu nu into D G mu nu. Proved. Thank you for watching my video. If you are satisfied with my presentation and contents, then please click on like button and do subscribe my YouTube channel.